This is a raw file from the state that was the item skills analysis tool that was sent out after the June 2011 exam. And these are we see off to the right here. These are the responses of the students for each question. I mean, that's a lot of hard work to get get data out of that in that format. So what have we done? We've taken the student results and we've put them into a set of score distributions by grade level. So this was the total. There's something like 342 students sat for the exam, and we've got the entire cohort here, and the greater than 65%, and between 55 and 64, and less than 54%. Then we've broken it down into grades. So this is the freshman class from that June 2011 year, and the grade 10 repeaters in that year, the grade 11 repeaters probably for the second time, and the grade 12 repeaters for the third time. We would have to consider these students as LTAs. I mean, how do you get 30% on an integrated algebra exam if you turn up to every class? Anyway, the idea is to try and identify these students and make sure they're in the right instructional groups in the following year, so they get a chance to pass. This group, you'd think, if they're well programmed, could perhaps pass the January Regents in the following year. Certainly another group here, but it's harder work to get to this 45 to 54 group. The object is, though, to dig back into the data and find out who those students are and see that they're programmed correctly or they're put in some intervention classes for the following year. The item analysis is much more interesting for integrated algebra, and that's obviously because we know what the questions are. Here are the standards: identify and factor the difference of two perfect squares, and here in fact is the question. And we can look over here at the responses, the number of students for each response, and the big distractor is option 1, x minus 6y, x minus 6y. They clearly didn't understand difference of perfect squares. And that should have been the comment here, that the x plus y, x minus y is not fully understood. And we can go right through every one of these and see what these large distractors are. Monomial, what's this? Divide monomials using exponent rules. And here we go. And we could see what option 2 is the big distractor. Option 2 here's the distractor. And option 2, negative 3 into 4, 4, W9, 3, they've divided instead of subtracted. Okay? The 3 into 9 goes 3, 3 into 3 goes 1. You know, great professional development here. And I've made some comments for some of the really big ones, and there are clearly plenty of other comments that could have been made. Okay, so then we've done the item analysis for the grade 9 repeaters. So anyone who is picking up a group of grade 9 repeaters has got some pretty good information here as to where their weaknesses were. Same with 10, and I've combined 11 and 12. So that's pretty much what I would plan to do with all the classes, all the subjects in the high school. I think this is terrific professional development for a math department to be able to sit and discuss, particularly if you have this on screen and you can see what the standards are, you can see what the question is, you can see what the alternatives are, and you can look to see where the distractors are. Okay, good luck.